Hello everyone, this is Prabhakar Marikani and I will be presenting on the topic Package on Package Encapsulated Semiconductors. Before going further into the discussion, let me give you a brief overview of what I will be talking in this presentation. First, I will be discussing about what is stack package and why stack package is needed nowadays, and then different types of stack packages available, particularly about package on package semiconductor. Then about the configuration and application of package on package semiconductor, and about the PGA array balls used in the package on package semiconductors design. Then I will be discussing about different methods used for assembling the semiconductors like single pass reflow and two pass reflow sequence, and the flux medium used to connect the packages to the PCB board, and the number of steps involved in reflow operation. Finally, I will elaborate on the advantages of package and package semiconductor technology. First, we will see what is stack package and why it is needed. Nowadays, consumers expect electronic products to be compact in every aspect, and this has been the major driver for the move towards increasingly smaller consumer electronic products. As a result, companies are focusing on bringing out compact electronic products such as mobile phones, video game consoles, and media players. Nowadays, companies are trying to reduce the board size so that they can reduce the overall size of the end product, which is being achieved by using these stack packages. It is a promising solution offering high integration that leads to miniaturization. Among various stack packages, package on package and package in package are increasingly becoming important in the packaging industry, especially in the mobile phone application, as they enable the stacking of high density logical devices. Here in this presentation, we are going to discuss mainly about package on package semiconductor. It is a modern integrated circuit packaging method to combine vertically discrete logical devices and memory ball grid array package. In this, two or more packages are installed atop each other with a standard interface to route signal between those packages. This structure allows higher component density in devices such as mobile phone, personal digital assistants, and digital cameras. This is the general architecture of package on package semiconductor, with the top package connected to the bottom package by means of using grid array balls, and this structure will be connected to the PCB board using the same grid array balls which are present below. Top package can stack 2 to 4 memory dies and bottom can stack 1 or 2 logical dies. Generally, height of this whole semiconductor depends on the number of memory and logical dies which are present within the package. From the previous slide, we learned that PGA is used for connecting top and bottom packages and with the PCB board. This PGA is a type of surface mount packaging chip carrier used to mount devices permanently. It provides more interconnection pin for dual in-line or flat package. This picture is a typical structure of grid array of solder balls under an IC chip. Here we can see that the chips were removed so that the balls were left attached to the PCB board. Here are some of the advantages and disadvantages of using PGA balls. Advantages are it provides high density due to close packing of pins. It prevents overheating of chip by providing good conduction. With low inductance lead, it provides superior electrical performance to pin devices. Some of the disadvantages are they are not mechanically compliant as they cannot flex in the same way longer lead can. It is very difficult to find soldering faults once they are soldered into place, and very expensive equipments are needed for soldering. Here is a side view structure of package on package semiconductor. The package on package semiconductor can be configured in two ways. The first method is pure memory stacking. In this, both bottom and top packages contains only memory dies, and the second method is mixed logic memory stacking. In this, bottom package contains only logical dies and the top package contains only memory dies. Every package on package semiconductor will have two states. They are unassembled state and assembled state. The state in which packages and PCB board are not connected with the PGA balls are called unassembled state, and once they are connected with the PGA balls, it will be in assembled state. Next, we are going to discuss about the method used for assembling package and package semiconductor. Two commonly used methods for assembling package and package semiconductor are single pass reflow method and two pass reflow method. This method is also known as pre-stacking method. Then about the fluxing medium used for assembling this semiconductor, and then we will discuss about the steps involved in reflow operation. First assembly method is a single pass reflow method. It is the most simplest and cost-effective method. In this method, high-density digital logic devices, that is bottom packages, are first pasted onto the printed PCB board, and then the high-capacity memory devices are placed onto the bottom package using the flux or paste dip medium. Then the whole assembled part will be sent through the reflow oven. Because of this simplicity and good manufacturing yields, it is the most recommended industrial method. This picture clearly explains the sequence of operation involved in single pass read flow method. First, the bottom package is placed on the PCB board, and then the flux medium will be applied to the top package and it will be connected to the bottom package. This is a simple flowchart for single pass reflow method. Here, first PCB board will be stencil printed and then bottom package will be placed over the PCB board. Then we will apply the flux medium over the top package, and the top package will be fitted over the bottom package, and the whole assembly will be forced to send into the reflow assembly method. In the reflow assembly, the flux medium will be checked whether they are completely clean or not. If they fail the cleaning test, it will be put into the cleaning process. Once they are completely clean, they will be sent to the downstream process. The second method is a two-pass reflow method. This method is also known as pre-stacking method. In this method, both bottom and top packages are mounted independently of the PCB board. That is, first top package will be connected to the bottom package and then the whole assembly package will be connected to the PCB board. Compared to the previous method, this method requires additional fixers, process steps, manufacturing control and trained personnel. While this assembly is more complicated when compared to the first method, this method allows us to perform full functional test on the assembled package on package prior to the final PCB assembly. This picture shows the sequence of operation involved in pre-stack reflow method. Here we can see top package and bottom package are pre-assembled before they are connected to the PCB board with paste print. This is a flowchart for pre-stack reflow method. As we discussed earlier, top packages and bottom package will be connected first. Once the functionality tests are performed, they will be placed over the stencil printed PCB board and then they will enter into the reflow assembly method. In the reflow assembly method, the flux medium will be checked whether they are completely clean or not. If they are not clean, they will be sent to the cleaning process. Once they are completely clean, they will be sent to the downstream process. Fluxing medium is normally applied over the ball which is used for attaching one packages over the other package. The top memory is not attached to the PCB board but to a thin individual package. This has a significant limitation since paste cannot be effectively stencil printed onto the bottom package, which leaves ball dipping as a reasonable process available. The preferred fluxing medium varies from one method to the other method, and it is a function of pad metallurgy and pitch. Each medium has its own advantages and disadvantages. This allows the end user to use any particular medium based on their needs. The table here depicts the results of trials performed with both flux and paste. The purpose of ball dipping is to transfer flux or paste to each ball thoroughly. Foreign material on these components or in the flux can cause some issues. Next, we are going to discuss about the steps involved in reflow operation. Package on package assembly reflow is similar to lead-free PGA profile requirements. The reflow specifics are largely dependent on the alloys and flux medium as well as the board layout itself. The first step involved here is to design the PCB board. It is very important to design the PCB board with pads for each and every balls along the silk screen outline to make it easy to align the components. The next step is applying flux over the board prior to doing the reflow process. If flux are not added, then oxide over the top of the pads will create some slightly squeezed balls which will not be connected to the PCB board. Next, all the components, that is packages, should be aligned properly over the PCB board. Then we need to place the PCB board in heated oven. The oven temperature can vary from 180 degrees Celsius to 210 degrees Celsius. It is very important to keep an eye on the temperature, because if the temperature extends beyond 230 to 240, then PCB board will be burned. Then we can turn off the roaster oven. Then we need to allow the PCB assembly to be cooled down for some time. The final step and the very important step is to inspect that all the balls are connected and that the component is strongly attached to the PCB board. This picture is the final result of the POP assembly reflow method. Next, we are going to discuss about the advantages of using package on package semiconductor technology. The most important advantage of using this semiconductor over isolated chip packaging is that it allows us to save more motherboard space. This package-on-package semiconductor uses much less PCB area, almost as little as stacked die packages. Electrically, package-on-package semiconductor offer benefits by minimizing the track length between different interoperating parts such as a controller and memory. This yields better electrical performance of devices since shorter routing of interconnection between circuits yield faster signal propagation and reduce noise and crosstalk. And the advantages of using this package and package semiconductor over chip stacking or the memory package can be tested separately from the logic package. Only known good package are used in final assembly. Comparing this to the stacked die packages where the entire set is useless and rejected if either the memory or logic is bad, the end user controls the logistics. This means memory from different suppliers can be used at different times without changing the logic. The memory becomes a commodity to be sourced from the lowest cost supplier. This trait is also a benefit to package in package, which requires a specific memory device to be designed in and sourced upstream of the end user. Any mechanically matching top package can be used. For a low-end phone, a smaller memory configuration may be used on the top package instead of using a higher end. And because the memory only comes into the mix at final assembly, there is no need for logic suppliers to source any memory. With a stacked die device, the logic providers must buy wafers of memory from a memory supplier. To sum it up all, stacked packages offer high integration that leads to decrease the overall size of the end product. Package in package and package on package are the type of stacked packages used in industries nowadays. Package on package is the most commonly used method. Package on package combines vertically discrete logic and memory ball grid array packages. PGA is a type of surface mount packaging used for integrated circuits. Package on package semiconductor technology has two states. They are unassembled and assembled state. Single pass and two pass reflow method are the method used for assembling the package on package semiconductor technology. And the flex medium, which is used for combining the top package and bottom package in the package on package semiconductor technology, depends on various factors. Then we discussed about various advantages of using package on package semiconductor technology over traditional isolated chip packaging and chip stacking. That completes my presentation on package and package semiconductor technology. Thanks for watching this video.